This is Cambridge Additional Mathematics paper, year 2019, October-November, variant 12. As I divide the paper into two parts, first part consists of question 1 to 6 and I am solving it. At question 1, on the axis below, sketch the graph of y equals to 2 cos 3x minus 1 for 90 degree less than equals to x less than equals to 90 degree. At first, I consider the graph of y equals to cos x. And this is x-axis, this is y-axis, and this is the graph, and it cuts x-axis at 90 degree, 270 degree, 270 degree, and here is 270 degree, and consider this point. Here is 180 degree and here is 360 degree, 360 degree, 360 degree. Now, if I this is if I sorry and it cuts, the curve cuts y-axis at 1 and minimum value here is minus 1. Now, if I consider y equals to cos 3x, to sketch this graph, this x coordinate has to be multiplied by 1/3. And this is known as horizontal stress of scale factor 1/3. And if I consider this, y equals to cos 3x appears like here is 30 degree and here is 60 degree and here is 90 degree. Now consider 2 cos 3x. Yes, I can two cos 3x. And here is 30°, here is 60°, and here is 90°, and here is 2, and here is minus 2. But we have to draw y equals to cos 3x minus 1. Therefore, this graph has to be translated along y-axis by scale factor minus 1, or move this graph vertically below y-axis by 1 unit. And if we do this, it appears like this, and this, and this, 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 this. This is the graph of y equals to cos 3x minus 1. Now, write down in this question, write down the amplitude of 2 cos 3x minus 1. We considered this 2 as amplitude. Now write amplitude equals to 2, and period of y equals to cos x is 360. Therefore, cos 3x is 360 multiplied by 1/3 is 120°. Now write 120°. Now, this is question 2. LG, question 2, when LG y square is plotted against x, a straight line is obtained passing through the points 5, 12 and 320. Find y in terms of x, giving your answer in the form of y equals to 10 to the power ax plus b, where a and b are integers. Here 2 points of the straight line are given, are 5, 12 and 3, 20. Now gradient of the straight line. Gradient, the straight line, 20 minus 12 by 3 minus 5 equals to 8 by minus 2 equals to minus 4. Now equation of the straight line, equation LG y square minus 12 equals to minus 4 x minus 5. Implies that LG y square equals to minus 4x plus 20 plus 12 is plus 32. Now LG, meaning of LG is log, LG is log to the base 10, and if I write this expression without logarithm, it gives y square equals to 10 to the power minus 4x plus 32. Now y equals to square root of this whole thing, or power of this whole thing is half. Therefore it is y equals to 10 to the power minus twice x plus 16. And question 2 is done. Now question 3. First three terms in the expansion of 1 minus x by 7 whole to the power 14 multiplied by 1 minus twice x whole to the power 4 can be written as 1 plus x plus bx square. Find the value of each of the constants a and b. This is in fact the sums of binomial theorem. I consider 1 minus x by 7 whole to the power 14 and expand it using binomial theorem, and it follows as 1 to the power 14 plus 14 C1 into 1 to the power 14 minus 1, 13 into minus 6 by 7 to the power 1 plus 14 C2 into 1 to the power 12 and x minus minus x by 7 whole to the power 2 plus n 1 14C1 is 14 and from here minus 1 by 7, therefore this here is 14 into minus 1 by 7 is minus 2i6 plus 14C2 is 49 and 1 by 7 whole square 14C2 is I calculate using calculator. 14 C2 is 91 into from here 1 by 49 and here is 7, here is 13, therefore 13 by 7 x square. Now I expand 1 minus 2i6 whole to the power 4, 1 to the power 4 plus 4c1 into 1 to the power 4 minus 1, 3 and minus 2i6 whole to the power 1 plus 4c2 into 1 to the power 4 minus 2 is 2 and minus 2i6 whole to the power 2. Now one 4c1 is 4 multiplied by minus 2i6 is minus 8x, 4c2 is 6 and from here is 4, 24 x square. Now 1 minus x by 7 whole to the power 14 multiplied by 1 minus 2i6 whole to the power 4 equals to 1 minus 2i6 plus 13 by 7 x square into 1 minus 8x plus 24 x square. Now multiply this whole thing by 1 gives 1 minus 8x plus 24 x square, and this by minus 2x gives minus 2x plus 16x square, and this by 1 gives 13 by 7 x square, and 1 minus 10x. 24 plus 16 is 40, plus 13 by 7 is 293 by 7 x square. Therefore, A equals to minus 10 and B equals to 293 by 7. And now I am going to next sums 4, question 4. On the axis below, sketch the graph of y equals to modulus of twice x square minus 9x minus 5, showing the coordinates of the points where the graph meets the axis. At first, I consider y equals to twice x square minus 9x minus 5. Twice x square minus 10x plus x minus 5. Twice x minus 5 plus 1 x minus 5, x minus 5 twice x plus 1. If y equals to 0, x equals to minus 5 and x equals to minus 5, x equals to 5 and x equals to minus half. Therefore, this graph cuts x-axis at point minus half, 0 and 5, 0. Now consider for values x greater than 5, y is positive. For values of x, here is minus half. For values x less than minus half, this y is positive. Therefore, this is the graph of y equals to this. But here we have to draw this, sketch this. Here is minus 5 and since modulus of 2x square minus 9x minus 5, therefore this negative part has to be reflected in the line x-axis, and it gives this. Now I remove the negative part. And this point is 0, 5. Now part 1 is done. Now part 2, find the values of k for which modulus of 2x square minus 9x minus 5 equals to k has exactly two solutions. This is the graph. And here is minus half, here is 5, and this point this point is the stationary point, and I try to find the x coordinate of the stationary point, and can be found by considering this symmetry. Therefore x coordinate of the stationary point 5 minus half by 2, it gives 9 by 4. Then y coordinate of the stationary point modulus of 2 into 9 by 4 whole square minus 9 into 9 by 4 minus 5. This gives 121 by 8 plus minus. Since this is positive part, this coordinate here is 9 by 4 and here is 121 by 8. Now if I draw a horizontal line y equals to k, it exactly cuts the curve at two distinct points, and it is above this point, this stationary point. Therefore find the values of k. Therefore k greater than 121 by 8, and this is done. Now question 5, it is given that function fx and its domain x greater than 0, greater than equals to 0, and gx and its domain is also given. Now this equals to identify each of the following function with one of f inverse, g inverse, fg, gf, f2, g2. Now this x square root of x plus 5 is sorry this equals to f gx, and this x minus 5 equals to g inverse x, and this equals to f inverse x, and this equals to g x equals to g 2x. Now part B, it is given that Sx equals to a plus b by x square, where a and b are constants. At 1, y is minus 2 less than equals to x less than equals to 2, not a suitable domain for Sx. Consider the function Sx. This graph, this curve, belongs to the category of y equals to 1 by x square, and if I sketch this here, this is the curve, and this is x-axis, this is y-axis. At y-axis, x equals to 0. Therefore, line of asymptote is y-axis, or equation of the line of asymptote is x equals to 0. It means that the curve never meet this x equals to 0. Definition of function, if we consider the definition of function, a function is there is a continuity in the function. If any discontinuation is observed, it is not the function. Therefore, from if I consider this in this limit, there is x equals to 0, but Sx is not defined for x equals to 0, or Sx has a discontinuation at x equals to 0. Since you can write Hx is not defined for x equals to 0. And now question 2, here is given that h1 equals to 4 and h prime 1 equals to 16, find the value of a and of b. Well, Hx equals to a plus b by x square. Now h1 equals to a plus, put the value of x here, and it gives b, and value of h1 is 4, and this is equation 1, and here is h prime 1. H prime x is first derivatives, or you can call you can consider if Hx is differentiated with respect to x, the result is h prime x. Usually we consider this dy by dx, but h prime x is also the same thing. It is Leibniz notation, and dy by dx is Newton notation. Since they both independently developed calculus, and I am not going to this discussion. I simply differentiate this Hx and h prime x equals to minus 2, the power of x is minus 2 here, 2b x to the power minus 3, and h prime 1 equals to minus 2b by 1 to the power 3 means 1, and equals to 16 as given. Now b equals to, therefore b equals to minus 8, and put the value of b in equation 1 gives a minus 8 equals to 4. Therefore a equals to 4 plus 8. A equals to 12, and this is done. Now I am at question 6. Write square root of p multiplied by qp by r whole square divided by p to the power minus 1 and cube root of qr in the form of this. Now write square root of p and qp by r whole square by p to the power minus 1 and qp qr cube root of qr. This gives p to the power half and into q square p square r square by p to the power minus 1 q to the power 1/3 r to the power 1/3. Now if I start from here, equals to p to the power half plus 2 plus 1 into q to the power 2 minus 1/3 by r to the power 2 plus 1/3 and it gives here is p to the power half 2 and here is plus 1. Therefore p to the power, this whole thing gives 7/2 and this whole thing gives q to the power 5/3 and r to the power 7/3, but r here is denominator. We have to write as r as numerator. Therefore the power of r would be minus 7/3. And now a equals to 7/2, b equals to 5/3 and c equals to minus 7/3. Now question part B, log x to the base 7 plus 2 log 7 to the base x equals to 3. log x to the base 7 plus 2 log 7 to the base x equals to 3. Now log x to the base 7 plus, since this base x from x to 7 gives 2 log 7 to the base 7 log x to the base 7 equals to 3. Now let log x to the base 7 be y, and the expression is y plus 2 by y equals to 3. Now it gives y square minus 3y plus 2 equals to 0, and y square minus 2y minus y plus 2 equals to 0, and y minus 2 minus 1 y minus 2 equals to 0, y minus 2 and y minus 1 equals to 0. Y equals to, therefore y equals to 2 or y equals to 1, and log x to the base 7 equals to 2. Therefore x equals to 7 square equals to 49, and here log x to the base 7 equals to 1 and x equals to 7, and the question 6 is done, and I have to finish my class here, but I am here want to say something about me. I have been teaching mathematics and physics at O and A level over 2 decades. This is an endeavor to express myself online. Those who think this class is beneficial for them can join my class. I regularly will upload classes considering your choices. Please do not forget to give feedback regarding to my classes. I have planned to make some classes on SAT, GMAT, GRE, especially on mathematics section. Even on mathematics and physics subject test for SAT. Now I have to finish my class here, and here is the end.